All right, so let's take a look at the next problem. A little simpler. Again, with a fraction equaling a fraction, and you have variables in there, the easiest way to solve these type of problems is cross products. So I'm going to be taking 4 times x plus 6, and then the other side, that means it should equal 5 times x. When I look, there's, well, first, I guess maybe you'll see it better here. There's distribute 4x plus 24 equals 5x. And this is the same type of x. So if we go back to what we did in that very top problem, here, we ended up getting x by itself, one type of x. So that's what we're going to do here. So I just need to kind of join those two x's. So I'm going to subtract the 4x to join the 4x. I'm sorry, the 5x. And when I do that, there's my answer. X is 24. Now again, with a denominator, denominators can't be 0. So I just want to make sure that 24 isn't an extraneous solution or an excluded value. And what I did not do is kind of go a step B, and that I need to talk about my domain or my excluded value. So I would not pick in my problem for the left fraction 0, and for the right fraction I would not pick -6. And I just want to check that my answer is also not part of those, because if it is, then it's considered an extraneous solution. So again, when you have a fraction equaling a fraction, then what you need to do is use cross products. All right, so moving on, what happens if you have a couple fractions equaling a fraction? Then what we're going to do is you're going to see it's a little bit similar to the adding and subtracting part, where we have to find least common denominators. So the first thing I'm going to suggest you do is you add the opposite. That's step A, and that's just only in between fractions, not within the fraction. So for instance, in the problem on the left, that -6, I would want to add the opposite. And the -3 here, that doesn't matter, so I'm not going to worry about that. So that's the adding the opposite here, okay? So the next thing I'm going to do is I'm going to just factor my denominators all the way. So again, maybe this is a good idea to get your green page out, and remember, all factoring starts with a greatest common factor. So in my first fraction, that's what I can do. I can take out an x and get an x minus 3. My second fraction, I can't factor, and my third fraction, I cannot factor. So hopefully at this point you can see that the least common denominator, because that's what the next thing we're going to have to do. Well, in just a second, sorry. What I should do now is up here is we did this, just identify the domain and the excluded values. And we always do that in factored form because it's just easier to see what would make it 0. So far, I would not pick 0 for this or this, and I wouldn't pick 3. Okay? So now what I'm going to do, if you need to, is the next step is I'm going to be finding the least common denominator. So again, if you don't see it, you can always make that fraction table. So I'm going to write this down, but I will be erasing it in just a moment. So here I have 3 fractions. So I have fraction 1, and I would put x and x minus 3. And then my second fraction, its x minus 3 would join this x minus 3. And then in my third fraction, the x would join this x. And then when you bring everything down, this is your least common denominator. And I'm going to wrap this in parentheses. So just a quick note, our LCD is x and x minus 3. Okay, so I'm going to be erasing the fraction table because I need the room. All right, so let's talk about what makes this problem difficult. It's the denominators that make this difficult. If these denominators were just gone, if none of this even existed over here, these problems would be a lot easier. So what we're going to do, is I'm going to unscribble those first, is we're actually just going to get rid of the denominators, and that's the purpose of the least common denominator. So what we're going to do is we're going to multiply the numerator in each term or fraction by the entire least common denominator. What this is going to do is it's going to cancel out common factors of each term or fraction, and what will happen is your denominator is just going to disappear when you do this step. So what I'm going to do is go to my first problem, the one we're working on. I'm going to multiply each fraction, which is a term. Terms are separated by addition, subtraction, equal signs, and I'm going to multiply the numerators by my LCD. So I'm going to multiply this one by x and x minus 3, and I'm going to multiply this one by x and x minus 3, And I'm going to multiply this one by x and x minus 3. Remember, if I'm going too fast, pause it and catch up. So what's going to happen is the denominator is just going to disappear. So this x squared minus 3x, which is actually just this in factored form, this x is going to take out this x, and this numerator of x minus 3 will take out this new denominator of x minus 3. So from my first fraction, what I actually end up having left is just an 18. So what's going to happen in my second fraction is the numerator of x minus 3, because remember, it's in a numerator spot, is going to take out the denominator of x minus 3. So what's left from this fraction, sorry, this should not be an equal sign, it should be a plus sign. That's what's connecting them to, is a negative 6 with an x, and they're multiplying. And then here comes my equal sign. And then in my last fraction, this x will take out this x. So I'm left with 5 and x minus 3. And now the problem is much more doable. So the reason this works is if I change one term by multiplying it, you know, like one term by, I didn't want to do that, by multiplying it by x and x minus 3, then I just have to do that to every term. And that's what allows me to do this is, you know, I'm changing everything by the same amount. So anyway, what I'm going to do is start to solve. I'm going to distribute this 5. Let's get rid of it. And if you see, there's just one type of x, so I'm going to work on getting the x's alone. So when I have a choice between in moving the x's, I'm going to move the negative 6 over. I'm going to add a 6x, and that gives me 11x. Now to get x by itself, I have to move the 11 and the 15, so I'm going to add 15 to the other side. And now to solve for x, I'll move the 11 by dividing, and when I'm done, I get x is 3. So this is my answer. I just want to go back to the top and just make sure it wasn't one of my answers and of my domain issues. And as you guys can see here, it is. That means although I solved and I got 3, 3 is considered an extraneous solution. It won't